So on page 32 is where we are going to glue the notes for standard form. You need to make sure that you glue them as far to the top of the page as you can, as you are going to write underneath them. So standard form is the very first form of quadratic equations that we're going to deal with, and you need to be able to recognize it. So we have y equals ax squared plus bx plus c. And as I talked about on page 30, the x squared, that is your quadratic term. The x is your linear term. And the c term is just your number, which is your constant. Now, we are going over these notes, and you're not using a calculator, because if you have a calculator, you would be able to find all of this stuff using the graph and the table. So we are going to pretend that you do not have a calculator to use, and you should not be using a calculator to help with these calculations. These would be on the non-calculator part of the EOC. So you are only given the equation. We are just given the equation, and you have to know how to find these characteristics without using a calculator. So concavity. Concavity, as you know, tells us if the graph is either up or down. So how can you tell that from just the equation and nothing else? If this a value out front is a positive number, then your graph would be shaped up like a cup. If that a value out front is negative, then it would be down like a frown. So all you have to do is to look at this very first number, and if it's positive, it's concave up. If it's negative, it's concave down. Your axis of symmetry. In standard form, to find this, you have to know this equation. X equals negative b over 2a. It's a fraction. Negative b over 2 times a. The b and the a represent the numbers from the equation that you were given. So you plug those in. You would plug b in on top and a in on bottom, and you would calculate your axis of symmetry. Your vertex. Once you find that axis of symmetry value, you are going to plug the axis of symmetry in for x and solve for y. You have to remember that your vertex is written as a point. So one more time, you are going to plug the axis of symmetry in for x and solve for y. So once you get an x value up here with negative b over 2a, you then are going to use that value to plug in and find your vertex. Your increasing, decreasing intervals, you are going to determine the concavity first, simply by looking at your a value. That will allow you to sketch the curve and then plot that vertex point as either the maximum or the minimum. And then you're going to state your increasing, decreasing based off of that little picture. Roots and zeros. You can kind of cross off number 5 here. In standard form, you cannot find the roots or zeros if you are only given the equation. So one more time, roots, zeros, solutions, you cannot find them if you are only given your standard form equation. And then lastly, y-intercept, you are going to plug 0 in for x and solve for y. The y-intercept is when x equals 0. So into your equation, you are going to plug 0 in for x and solve for y. And then don't forget that this is a point 0, y. Okay, underneath here, we are going to fit most of the example on the handout itself. And then you might have to finish writing in your notebook. So under here, we're going to do an example. And that example is y equals x squared plus 2x plus 3. So in your head, you need to be thinking there are no parentheses, so this is standard form. Before we do anything else, we're going to state what A is, what B is, and what C is. A is the number in front of your quadratic term, so A is 1. B is the number in front of your linear term, which is 2. C is the number at the end, or just your constant, which is a plus 3. And now we're just going to run through the 6 key features that you need to be able to find from standard form. So the very first thing is concavity. So concavity is based on your A value. And in this case, we said A was 1. It is a positive A, a positive 1. So positive A value tells you that this graph will be concave up. The second thing in the notes above in the table is your axis of symmetry. To figure out your axis of symmetry from standard form, you use that formula, x equals negative b over times a. So instead of a, we're going to plug in 1, and instead of b, we're going to plug in 2. So negative, instead of b, we're going to plug in 2, over 2, instead of a, we're going to plug in 1. Now you don't have a calculator, because if you had a calculator and you were asked to find these key features, you would use the graph and the table in your calculator first. So on top, negative 2 is just negative 2, and then 2 times 1 is 2. And then you're going to reduce. Negative 2 divided by 2 is negative 1. And your symmetry is the equation x equals whatever that number is. So our axis of symmetry is x equals negative 1. The third key feature is your vertex. So for your vertex, you're going to take your equation, which is y equals 1x squared plus 2x plus 3. Where did I get that from? It was given to me as an example. And what you're going to do is instead of these x's, you are going to plug in this axis of symmetry. So y equals 1. Instead of the x, you are plugging in that axis of symmetry of negative 1 squared plus 2. Instead of the x, you're plugging in that negative 1 plus 3. Now you don't have a calculator, so you're going to have to break down these steps. So 1 times, you're doing negative 1 squared, which is just negative 1 times negative 1, which is positive. And then we're going to do 2 times negative 1, which is negative 2. And then this plus 3, we've got nothing to simplify. 1 times 1 is 1. So we have 1 minus 2 plus 3. Negative 1 plus 3 is a positive 2. So we just solved that y equals positive 2. Your vertex is a point. You took this axis of symmetry and you plugged that in for x, and you found that y is 2. So this is your vertex. Your vertex is the point negative 1, 2. And that's all that fit on my notes paper. I am not going to do increasing, decreasing intervals for this example because there's not enough space on this page. So glue this down, and then we will go ahead and do number or key feature 6 underneath. So I'm not doing increasing, decreasing because there's not enough room on this page. You cannot find roots and zeros, but we can find our y-intercept. So our y-intercept, you take this equation that we were given and you plug 0 in for x. So 1, instead of that x, we're going to plug in a 0. Plus 2, instead of that x, we're going to plug in a 0, plus 3. Well, 1 times 0 squared is 0. 2 times is 0. We've got plus 3. So 0 plus 0 plus 3 is just 3. So we just found that y equals 3. But again, your y-intercept is a point. We plugged 0 in for x and then solved that y was 3. So our y-intercept is the point 0, 3. So on your page 32, should look very similar to mine. You should have all of these notes filled in and finishing example or part 6 down the bottom. If you needed to, you could work example 6 up the side. It doesn't matter, or get a Post-it. But you should have that all on page 32.